This is a question from algorithms. Assume that f of n and g of n are asymptotically positive. Which of the following is correct? So before we solve this question, let's understand the three main asymptotic notations. The first one is big O notation. The second one is omega notation. The third one is theta notation. These are the three main notations. So what does these notations represent? Let's first of all let's see the theta notation. Theta notation essentially encloses a function from below and above. Since it represents the upper and lower bound of the running time, it is used for average case complexity of the algorithm. A simple graph representation of a theta notation would be like this. So this represents the time complexity. We can denote theta notation as follows. Suppose there is a function f of n, then it is bounded by two other functions. One is g of n or g1 of n we can say, and the other is g2 of n. Then there will be two constants c1 and c2. c1 multiplied by g1 of n and c2 multiplied by g2 of n after this point n0. We can say that after this point n0, f of n is bounded by g1 of n and g2 of n. So this represents the average case time complexity. This is theta notation. The next one is big O notation. Big O represents the upper bound of the running time complexity. Therefore, it gives us the worst case time complexity of the algorithm. The basic graphical notation would be like this. So for big O, we are having a function f of n. Then there is another function c into g of n such that beyond the point n0, f of n is bounded by c into g of n. So beyond n0, f of n will not go beyond the value of g of n. So it is worst case time complexity. And then we have omega notation, which represents the lowercase time complexity. That is, it represents the lower bound of the running time of an algorithm and it gives us the best case of the time complexity. So we can denote it like this. Suppose there is a function f of n, then there is another function g of n such that beyond the point n0, f of n won't go less than g of n. So this represents the average case, this represents the worst case, and this represents the best case. These are the three asymptotic notations, and these notations have different properties. One such property is the transitive property. It says that if f of n is omega of g of n and g of n is omega of h of n, then we can say that f of n is equal to omega of, or not omega, big O of h of n. These are all big O. So the properties, if f of n is equal to big O of g of n and g of n is big O of h of n, then we can say that f of n is big O of h of n. So based on this property, we can say that option C is the correct answer here.